In this video, we will show that the set C4 is equal to 1 minus 1 iota minus iota of all the fourth roots of unity is a group under the usual multiplication of complex numbers. Now coming towards its solution, the set of 4 fourth roots of unity is C4 equal to 1 minus 1 iota and minus iota. We have to show that the C4 forms a group. To prove that it forms a group, we will show that it satisfies all the four axioms of a group. Since number of elements are finite, so we will create a Cayley's table. Now let's construct Cayley's table. Here we will write the binary operation that in this case is multiplication, and in first row we will write all the members of the set that are 1 minus 1 iota minus iota, and in first column we will write all the members of the given set that are 1 minus 1 iota minus iota. 1 multiplied by 1 is 1, 1 multiplied by minus 1 is minus 1, 1 multiplied by iota is iota, and 1 multiplied by minus iota is minus iota is minus 1. Minus 1 multiplied by minus 1 is 1. Minus 1 multiplied by iota is minus iota. Minus 1 multiplied by minus iota is iota. Iota multiplied by 1 is iota. Iota multiplied by minus 1 is minus iota. Iota multiplied by iota is iota square, and iota square is equal to minus 1. So iota multiplied by iota is minus 1. Iota multiplied by minus iota is minus iota square, which is equal to 1. So iota multiplied by minus iota is 1. Minus iota multiplied by 1 is minus iota. Minus iota multiplied by minus 1 is iota. Minus iota multiplied by iota is minus iota square, which is equal to 1. Minus iota multiplied by minus iota is iota square, which is equal to minus 1. Now that we have constructed the Cayley's table, so we will check the axioms of the group one by one. All the answers that we got after multiplication are in the given set. So we can say that closure law holds. So first axiom is satisfied. Second axiom is associative law. For this we take any three elements from the given set. So let 1 iota minus iota belong to C4. We have to show that 1 dot iota dot minus iota is equal to 1 dot iota dot minus iota. Firstly, let's take the left hand side, that is 1 dot iota dot minus iota. 1 multiplied by iota is iota dot minus iota. minus iota multiplied by iota is equal to minus iota square, where iota square is equal to minus 1. So we get 1. So left hand side is equal to 1. Now let's take the right hand side, which is equal to 1 dot iota dot minus iota, which is equal to 1 dot iota multiplied by minus iota is equal to minus iota square, and minus iota square is equal to 1. 1 multiplied by 1 is equal to 1. So we can clearly see that left hand side is equal to right hand side. Therefore, associative law holds. So second axiom of group is also satisfied. Third axiom is the existence of identity element. From the table we can clearly see that whenever we multiply one with the other element, we get the element itself. So we can say that 1 belong to C4 is the identity element. So identity element exists and third axiom of group is also satisfied. Is the existence of inverse element. Whenever we multiply an element of the set with another element of the set and we get the identity element, then that element is called the inverse of the other element. We know that 1 is the identity element in the given set. So we will see when 1 is multiplied by 1, we get the identity element 1. So 1 is the inverse of 1. And when we multiply minus 1 by minus 1, we get the identity element 1. So minus 1 is the inverse of minus 1. When we multiply iota by minus iota, we get the identity element 1. So iota multiplied by minus iota is equal to 1, which means that minus iota is the inverse of iota. When we multiply minus iota by iota, we get the identity element that is 1. So iota is the inverse of minus iota. Since inverse of each element exists, so we can say that the fourth axiom of group is also satisfied. Since all the axioms of the group are satisfied, so we can say that therefore C4 is a group under binary operation multiplication. Which is the required proof.